Hello everyone, welcome. Today I'm going to be doing a proof of the power rule using the binomial theorem for integer powers specifically, right? So yeah, I'm just going to jump right into it. You probably recognize this limit as the limit definition of a derivative, right? So if I were to raise this to some arbitrary power n, let's say, yeah, x plus h to the n minus x to the n, all of that over h. The challenging bit is just trying to expand out this binomial, and this is what we have the binomial theorem here for. Right, so the limit as h approaches 0 of x to the n plus n choose 1 of x to the n minus 1 h plus n choose 2 of x to the n minus 2 h squared plus dot 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 h to the n, yeah, h to the n. So all of that over h. Oh, I forgot to add this. Minus x to the n. This comes straight from here, right? And all of this comes from expanding out this term over here. Okay? So these two x to the n's will cancel out, right? And if we try and simplify this expression a little bit and try and cancel out these h's, right, and this will become h, and this will become n minus 1, h to the n minus 1, you'll get, right, the limit as h approaches 0 of n choose 1 of x to the n minus 1 plus n choose 2 of x to the n minus 2 h plus dot 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 h to the n minus 1, right? And if we were to see what happens as h approaches 0, right, all of these terms, aside from this term, will have an h term in it, or will have an h variable in it. So the only term that will exist as h approaches 0 is this, right? So as h approaches 0, this is going to become 0, right? And this is going to cancel out. As h approaches 0, this is going to approach 0, and this is going to cancel out. And everything in between, the only term that you have that's left is n choose 1 times x to the n minus 1. And n choose 1 times x to the n minus 1 is just n, right? X to the n minus 1.